Okay, guys, let's go ahead and let's get started on a new section of notes. Today we are going to be starting Unit 2. Unit 2 is basically the foundation, the cornerstone of Algebra 2, which is getting into functions and graphs of functions. So in Target FG.1, the FG.1 notes that we are starting today is defining and identifying functions. In order to come up with a definition for functions, let's first take a look at problem number 1. So in problem number 1, it says for each of the following, substitute the given value for x into the given equation. Then match that x value with the corresponding y value. Determine which of the functions are relations. So we're going to take all these values in the x column, substitute it in for x, and figure out which y it would be. So 1a should be pretty easy for us to do. When we substitute in a negative 4, for x, y would be negative 4. When we substitute in negative 1 for x, y would be negative 1. If we substitute in 0, we would get 0. 1, we would get 1. And 4, we would get 4, because x and y are the same thing. So this one's pretty easy for us to go through. Now in b, it's a little bit more complicated. We're going to substitute in x or into y equals x squared. So initially we're going to substitute in negative 4. So negative 4 times negative 4 would give us positive 16. Negative 1 times negative 1 would give us positive 1. 0 squared is 0. 1 squared is also positive 1. And 4 squared is positive 16. Finally, on the last one, we have the square root of x. So we're going to substitute in it for x again. And notice that this is a plus or minus on the outside. So first, let's do the square root of 4, sorry, negative 4. So you may remember back from Algebra 1, if you try to do the square root of negative number, you get a non-real answer. So the square root of negative 4 is actually not going to go to anything in the y category. Eventually, we'll learn what we could do with that, but we're not there yet this year. Negative 1 would also not go to anything in the y category because it would be the square root of another negative number. The square root of 0 is 0. Now, the plus or minus doesn't matter for 0 because 0 is neither positive nor negative. So the square root of 0 is just 0. The square root of 1, we should know, is 1. But again, there's a plus or minus, so this is going to go to positive 1, but it's also going to go to negative 1. And finally, the square root of 4 is 2. And it again, we have that plus or minus out in front. So from positive, 4 goes to positive 2 and negative 2. Now, this is what we're going to use to establish a definition for a function. Two of these are a function. One is not. Take a look at A, B, and C and see if you can figure out which ones are a function and which one is not. If you said that A and B are functions and C is not a function, you would be correct. So a function is a relationship where every value from the domain or the input, the x values in this case, map to or match up with exactly one. Let's capitalize that to make it a little more pertinent. Exactly one value from the range or the output, the y values. So we see that in A, every x goes straight across to 1y. See that in B, every x goes to 1y. Now, some x's go to the same y, but each one of these numbers in the x column is only going one place. In C, we have the problem down here is number 1 and 4. Technically, negative 4 and negative 1 do not cause this to no longer be a function. But positive 1 and positive 4 do because they're going in two different directions. So to be a function, every input or every x value has to go to exactly one y value. So now let's take a look at some example problems. Problem number 2 says a relation f has the following points. So each of these points are on f. Is f a function? And explain. Well, we may look at this. Remember these points, the first point is an x, so this would be an x value of negative 3 goes with a y value of 0. So if I look at all these points, there's a couple points that may stick out to me. So one of those points that would hopefully stick out, or a pair of points actually, would be negative 3, 0, and negative 3, negative 2. Why would I take a look at those? Well, in this case, it's saying negative 3 is going to 0. In this case, it is saying negative 3 is going to 2. So negative 3 is going to two different y values. So can this be a function? The answer should be no. So if we wanted to explain our answer, all we would have to do is say that, no, this is not a function because, sorry, because -3 maps to two different output values or y values. And -3 isn't the only reason this is not a function, but it is one of them. You may also have looked at 4, 2, and 4, -5. So according to this, 4 also maps to two different output values. So it is not a function based on two different scenarios. Now let's take a look at problem number 3. In problem number 3, we're actually viewing some graphs. So in 3, it says consider the following 4 graphs which show a relationship between variables y and x. Identify which graph displays a function or graphs. It could be more than one. So if I take a look at the graphs here, we have a test to help us identify if this is going to be a function. If each input has exactly one output that it is mapped to. That test you may remember from Algebra 1 is called the vertical line test. So if I take a vertical line and I draw it here, my display, I should be able to pass through the vertical line, run it through any part of the graph, and it should intersect only once. And so we can see that here in problem number 1. This relationship, this vertical line is showing how many y values match up with each x value. And all the way through, it's only 1 with graph number 1. Now, if I look at graph number 2 and I start to pass it through there, I can stop right away. Because at this x value, at this x right here, we don't know exactly what it is, but we do know that there are 4 y values. So this does not pass the vertical line test. This is not a function. You can continue the same thing with 3 up. That can stop here because this x value has 2 y values. This is not a function. You can go further to problem number 4. And as I pass this vertical line through, it intersects only one time. And so each x value has only one y. And so problem number 4 would be a function. So out of this, it says which of the following graph or graphs are functions. We could say that 1, sorry, let me change that color there. We could say that 1 and 4. And then if we had to explain, we could say 1 and 4 pass the vertical line test. And we could elaborate that on that a little bit, meaning that each input value, each x value, maps to only one y value or output value. So if you did say that 1 and 4 pass the vertical line test, that would be good enough, but we can also elaborate that and relate that back to the definition. So this is basically how we're going to take a look at functions and determine if they are, or take a look at relations and determine if they're a function or not. Let's go ahead and look at problem number 4. Problem number 4 brings us into function notation, something that you may have seen a little bit of in Algebra 1, potentially a little bit of in geometry, but we're going to see a lot of in Algebra 2, so we want to make sure we have function notation down. So for example, if I have f of x equals y, and this we would say that f of x equals y. What this means is that it's basically giving us any xy coordinate pair. So the x is in the parentheses with the f, and the y would be what it is equal to. This is true for any function of any kind. So it's in problem number 4, it says given f of x. They tell us what f of x is. They tell us a function. Given f of x equals negative x squared plus 4x plus, evaluate each of the following expressions. We won't do D, but we'll do A and B and C. So in A, it's giving us f of 2. Inside that parentheses, what this means is my x value is negative 2. So if I want to evaluate this expression, I can just take the x and replace it with negative 2. And so I just replace or substitute each x value with my integer that I know is equivalent to x. And now I can simplify this expression. So if I wanted to, I could do this by hand, but you can also type this into the calculator at this point. That's good enough for showing our work here, showing the process. So I can type in what I see there in the equation and evaluate. So f of -2 is -16. So the y value, basically what this is giving us again, is an x of -2 that pairs with a y value of -16. Let's take a look at b. B is the same concept. In this instance in b, I'm going to write it a little bit lower for spacing. In this instance, x is 3/2, f of 3/2. So I would do the same thing. I'd take all of the x values and replace them with 3/2. And again, I can type that into my calculator or compute that by hand. And if I do so, I should have f of 3/2 is equal to 3/2. So then any x that's 3/2 on this function is going to have a y that is 3/2. Now let's take a look at c. In c, they give us a variable expression. But again, the concept is the same. I'm going to take 2a and put it in for x. So 2a is now my input value, my x. This is a function, so it's going to have one output value, one y, and we have to find what that y is by simplifying. Here we do need to simplify by hand. So 2a squared, we would square the 2 to get 4, we'd square a to get a squared. And then we can combine this multiplication by multiplying coefficients. So -8a squared plus 8a. If I wanted to factor that, I could, but this is good enough. So f of 2a is -8a squared plus 8a. So this is what function notation is. It gives us an x value and a corresponding y value. Let's go ahead and take a look at problem number 5. In problem number 5, we have a graph here. We're going to use function notation and the graph, combine ideas here to evaluate some different expressions. And then we're going to look at some features on the graph as well. So the first thing that we have to evaluate is f of -1. Remember, this -1 inside the parentheses is an x value. So it's representing an x value. So we want to find the corresponding y value. So what I'm going to do is I'm going to go on the graph, and I'm going to go over here to where x is -1. So this point at this location, I'll go ahead and label it, would be -1, 0. So f of -1 is going to equal the y value in that location, which is 0. We can do the same thing for any f of x value. So now we have f of +1. So if I go on the graph and I find +1 on the graph, there's the location. This point would be 1, 4. F of +1 is 4. See if you can follow that same concept to find f of 5. If you said f of 5 was -4, then you'd be correct. So we could find -5 on the, we'd find +5 on the x-axis. We'd find that point on the graph, on that curve, and it has a y value of -4. So f of +5 is going to be -4. Now let's take a look at B. It says evaluate f of 0. Same concept. F of 0 would be an x value that's 0. So we can find that on the graph here. And we would have this point 0, 3. So f of 0 is 3. It then goes on to say, what special feature on a graph does f of 0 always correspond to? Well, if we take a look at f of 0, it's this point right here on the y-axis. Anytime we cross the y-axis, this is known as the y-intercept. F of 0 is always going to be the y-intercept because it is the value or the location where x is 0, which is always on the y-axis. Now see if you can, now if we take a look at C, we're going to switch up the way that this is written. So if you wanted to try this on your own, you could, but I'm going to walk you through it. It says, what values of x solve the equation f of x equals 0? Notice that now the number is on the outside of the f of x expression. It's equal to f of x, which means by our notation that we're looking at a y value. So what we want to find is all the y values on the graph. So this point right here that I'm coloring in, we already found that one where y equals 0. But then there's a couple more. So in this location, at 3, 0, y is 0. And at this location, 7, 0, y is 0 again. So it says what values of x solve the equation f of x equals 0. There's 3 of them in this case, -1, 3, 4, 7. So there's 3 different locations for x that lead us to a y value of 0. What special feature is this? Well, each of these are on the x-axis. This is the x-intercept. So anytime f of 0 is being found, we're finding the y-intercept. Anytime f of x equals 0 is being found, we're finding the x-intercept. Finally, in D, it says, between which two consecutive integers does the largest solution to f of x equals 3 lie? So f of x equals 3. This is, again, a y value. So what we can do here is we can basically take a look at the line where f of x equals 3. I'm going to go ahead and kind of highlight that line here. So at each one of these places where that line intersects the graph, this is a solution for f of x equals 3. The largest one would be the furthest to the right. So this one is slightly beyond 7, but just shy of 8. So which two consecutive integers does the largest solution of f of x lie? Between 7 and 8. So in this case, again, we were looking for the y value that's 3 and the corresponding x values that match up with that. This is function notation in a nutshell. We can also do some function notation with tables, which we will see in the future. But this is a good place to stop for day 1 of FG.1 notes. Tomorrow in class, or today in class, depending on when you're watching this video, the next time we're in class, we will go over questions that we have, maybe take a look at some more examples, and then give you a chance to practice with some homework. Thank you guys for tuning in. I'll see you soon.